Okay, Unit 5, Lesson 4.5, we're going to be talking about probability and odds. So, if we just look down below here, we're going to see that odds are another way of describing an event, okay? Instead of using probability, we can use odds. So if I say something is odds in favor, I'm talking about that the odds that something will happen. I'm talking about the odds against. That means I'm talking about the odds that something will not happen, okay? Now, odds is a little different in terms of probability. The way it's different is the bottom number, instead of being the total amount of choices you have, it's basically now changed. It's got success divided by failure. And it's often written like this. It would be written with a colon, okay? So this would be 5 to 6. Now, it can also be written as a fraction, okay? Now, odds in favor is success to failure. If I want odds against, I literally flip those numbers, and it would be 6 to 5. Okay? That would be odds against. You literally flip the numbers of the order. Okay? Let's take a look at some more definitions here. So, as we just said, odds are another way of expressing the likelihood of an event occurring or happening. So, instead though, we are going to say the total is going to be a non-issue for us. This is the difference. So, instead of using probability of getting a 4, like we did on our six-sided dice, so if I said probability of a 4, I'd have 1 4 in 6 choices. That's probability. However, we're going to use odds. When I say odds, that means I'm going to have 1 being the favorable. How many would be non-favorable out of those 6 numbers if one of the numbers is favorable? 5 numbers would be non-favorable. So we would have 1 to 5. So that's why it's written this way, 1 to 5. Now what you're going to notice is both numbers, when you add them, they give you the total number, which is the bottom number for probability. Okay, so that's the difference. They add to the total. Okay, you don't use the total number, but they will add to the total. So, odds against rolling a 4, flip the numbers around, we just flipped 1 and 5, would be 5 to 1. So literally, 4 and against. So, we are using the ratio, so dot to dot, or it can be with a fraction. If it's a fraction, what they've done is they've taken the fraction and they've tilted it this way, so whatever's on the left shows up on top, whatever's on the right shows up on the bottom. And that's the way they've shown it here. So the left-hand side is on top, the right-hand side is on the bottom, and that's how they would show it. So don't get confused that if you see a fraction, that it's automatic probability. It's not always. They can show odds as a fraction. Okay? All right, so let's take a look here. We're talking about the numbers wanted versus the numbers not wanted. So, if I said to you, what are the odds of rolling a 1, a 2, or a 3 on a six-sided dice? Well, how many 1s are there? 1 out of 6. How many 2s are there? 1 out of 6. How many 3s are there? 1 out of 6. So here, we've got 3 numbers in our total. Well, if I've got 3 numbers are 1, 2, or 3, how many other numbers out of 6 are left? 3. So this is going to be a 3 to 3. Whenever the numbers are identical, you're going to math fraction like a normal fraction. You would just go 3 divided by 3, which just gives us a 1 to 1. So whenever we're talking about something like this, whenever this happens, where we've got identical numbers, we call those even odds. Okay, we've got even odds. So if we talk percentages, that's saying you got a 50-50 shot. And again, 50-50 would reduce to 1 to 1. So we got Tom here. It was originally Mr. Kennedy, but I changed his name to Tom because I figured I'd be nice to him. What's that? 50-50. If it was probability, it would be 1 out of 2. Okay? Tom's high school teacher told him he had even odds of graduating. So he had a 50-50 shot of graduating. So that means he's got a 1 to 1 shot. Okay? What is the probability of graduating then? 1 over 2, because we have to add the total. So 1 over 2, the total is on the bottom. Now, to get the total, what do I do to these numbers? I add them, and that's how I get my total number. Okay, so you add them to get the total for the bottom.
How do you know it's 1 on top?
Ah. When the minute it tells me he's got even odds, it's automatically 1 to 1.
Okay.
And the left-hand number is always on top. Okay, and this left-hand number is right here. This number is always on top. And then you've got to add them to get the bottom number.
So even if the ratio was like 2 to 1, then it'd be 2 on top and 3 on the bottom?
Yes. And we're going to have more examples like that coming up. So, second part to this question says, oh, a little bit later, he's been working harder. Now it says his chance of graduating has gone up to 0.65. Woohoo! So his probability of graduating is 0.65. So that's 65 over 100. And we need to make that go into lowest terms. So how big is 65 over 100? Math bracket. 13 and 20. Good. So that's his probability. We want the odds that he graduates. So that means odds in favor. So I need the top number. That's odds in favor. Okay, so I know I'm going to have a 13 to something. How do I find that second number? Any thoughts? We're going to take 13 plus something adds to 20. You could also reverse it and say 20 subtract 13. Okay, so your bottom subtract the top. So that's going to be 13 to 7. Okay, that is odds in favor. Okay, 13 to 7. They have to add to the total 20. Okay, so again, what is the difference between odds and probability? Probability is favorable over total, whereas odds, it's favorable to unfavorable. Okay, success to failure. It has nothing to do with the total. You have to add both numbers to get the total. Okay, that's the difference. So where do we use odds? Well, many probabilities and odds are based on actual data, specifically weather and sports. So forecasts, cancer survival rates, so in the health field, odds and probabilities are assessed, and then they make decisions for upcoming events. So for example, right now there's a lot of flus and colds going around. You know, all the schools in Sylvan Lake. One of the schools even sent a letter home saying, try and remind your kids to wash their hands lots, etc., etc. Don't share drinks, those kinds of things, because everybody's getting sick. So, what would they do for the next year flu shot? Well, they take the data and they analyze the data and they say, okay, well, what is the probability of someone getting the flu based on the last stats? Then what they would do is they would modify the injection for the flu shot that's going to make sure that more people don't get the flu. Okay, so they use a lot of the data that way. Same thing here. How is data going to impact an event? Well, definitely in hockey for sure. Any sports. All the March Madness for your basketball. All of that stuff. They are going to make decisions. This one in case point, they're going to make a decision who's going to do the shootout. Okay, you're going to take your best player. They're going to do it on stats. Maybe so-and-so hasn't been playing very well, but stats say he's your best player. Are you going to put him out? Probably. Okay, those kinds of things. So, example 4 talks about Vegas, because Vegas is where you see a lot of odds. What are the odds of winning against the house hand? So if you're playing blackjack, or you're playing poker, or maybe you're at the roulette wheel, what are the odds of you winning? Well, this is where it comes up. So, the next example talks about teams winning the Stanley Cup. So, I've got a bottom row down here. This bottom row is for us to fill in the probabilities. So, we need to make our separations, please, because mine didn't come through. And we are going to put a P here and find the probabilities for each. So, when they give me this data, this is odds in favor of them winning the Stanley Cup. Or sorry, odds against them. So this is odds against them winning. So, the way you read it is this. For every 9 times they don't win, they'll win once. For every 10 times they don't win, they'll win once. That's how you would read those, okay? So, we need to change it to probability. So the first thing we have to do is we have to reverse everything. Because everything is in odds against, we need odds for. So I'm just going to put it right above the actual digit. So odds for, reverse the numbers. 1 to 10, 1 to 10, 1 to 14, 1 to 16, 1 to 20, 1 to 33. Okay, so I've reversed the numbers. Now I need to do the probabilities. The probabilities are going to have the odds in favor, which is the digit that is first in those blue numbers I wrote. So each of them start with a 1. How do I find the total number now? For probability. Remember, probability, I need the total number. These are not the total numbers. That's how many times they'd win and then how many times they'd lose. Success and failure. You add them. So, my total on number 1 is 10. So, a 1 in 10 shot. They're going to win the Stanley Cup. What about the Oilers? 1 in 11. Add the digits together. The next guys, 1 in 11. The Ducks, 1 in 15. What about the Leafs? 17. 1 in 17. What about the Stars? What do they add to? 1 in 21. Okay, what about the Flames? What do they add to? 1 in 34. Good. Now that we've got the probabilities, now we can actually compare them. So it says, which one is most likely to win? It's going to be the guy with the lowest bottom number. So who's the most likely to win? The Penguins. Now, who's the least likely to win? The Flames, the ones with the bigger numbers. Okay? And now we want to know, on letter C it says, Edmonton Oilers odds 10 to 1 against. What does that mean in real words? How would we describe 10 to 1 against for the Oilers? That's right. For every 10 times they lose. So for every 10 times they lose the Stanley Cup, that means they actually get there. It's a reach, I know. For every 10 times they lose the Stanley Cup, they will win it once. I think Calgary and Edmonton should be switched on my diagram. That's okay. We're just going to be optimistic Oiler fans. All right. So that's the difference with odds. Now we're going to talk about my riders, because I'm a rider fan. So we got to talk about the chances of them winning. So on the bottom of the page it says, in a regular CFL season, the Riders have a 25% chance of winning the Cup. That's still a bit optimistic, but that's okay. Probability it will occur. Probability would be 25 over 100, which is 1 in 4. They have a 1 in 4 shot of winning. What would be the complement? 3 out of 4. Because what do the two top numbers have to add to? 4. They have to add to the bottom. That's how you find the complement, you guys. The two top numbers have to add together to give you the bottom. Okay, that's how you find the complement. So if this top number was a 7 out of 10, the complement would be 3 out of 10. Okay? The next one says, what is the probability of the complement as a fraction? Well, we did it already, 3 over 4. What are the odds in favor of them winning? All right. So the probability they're going to win is 1 out of 4 times. So how would I write that, 1 out of 4, as an odd, not probability? What am I going to do? So I need to go 1 dot dot something. 3. How do I know how to find that last number here? That's right. These two numbers have to add to give me my bottom number of my probability. Okay, that's how I know. The next one, odds against. What am I going to do to those numbers? Flip them. So it's going to be 3 to 1. Okay, so odds for and odds against, just flip your numbers back and forth. All right, couple more examples here. So, we have an expectant mother. Research says that having twins is 1 in 32 chance. So what are the odds in favor of a woman having twins then? If it's a 1 in 32 chance. So for every one time they're going to have twins, how many times won't they? 31, good. Why is it 31 and not 32? Right, it's got to be 32 in all. You have to add the 32. Good. Okay, now we're going to do odds against. What do I do to the numbers? Flip them. 31 to 1. Perfect. All right, let's take a look at the next one. Stephanie's told that the probability she's going to make a full recovery from her operation is 0.65. So in lowest terms, we want the odds in favor of her making a full recovery. Well, first of all, we need the probability as a lowest fraction. So you're going to math frac 0.65. That's the first step you always take. You've got to math frac that fraction there. So what are you going to get?
13.
Thank you very much. So, probability of a full recovery, R for recovery is 13 and 20. So, we want odds in favor, which means success, she will recover, to how many times she won't. So how many times won't she recover?
7.
They have to add to 20. They need to add to the bottom number. Okay, they have to add to the bottom number always. All right, the next one. Probability of winning a game is 7 in 15. We want odds of winning. So what's that going to be? 7 to what?
8.
7 to 8. Whatever adds to 15, right? You've got to get them to add to your total number. Okay, so remember, odds will add to your total. Last couple examples. We have, if the odds of winning, now remember I told you sometimes they put odds in a fraction. Odds is not always given with a colon. So in this time, I would strongly suggest to you to replace the fraction line with a colon. So this is actually 6 to 7. Okay? But they will sometimes put it as a fraction like they did here. So you have to remember it's written as odds. So odds, so you want the probability of winning. So probability of winning. Which number is the win and which number is the lose? 6 is the win, 7 is the lose. So we're going to have 6 on top. What's my bottom number? 13. We have to add them together. Okay? So we're going back and forth between odds and probability. If they want probability, you add both odds numbers. Okay? If they only want odds, the two numbers have to add to the total. So these two have to add to 13. Okay? Dudley, after suffering a severe heart attack, his doctor told him that he had even odds of making a full recovery. So what does even odds look like? 1 to 1. Good. So what is his probability of a full recovery?
Kennedy Rizik to the
1 out of
office,
a
please.
2.
Kennedy Rizik to the office. Thank you.
So the probability then, we have to add both odds numbers. 1 plus 1 gives us our total 2 on the bottom. Okay? This concludes probability and odds.